Hello everyone and welcome to today's webinar. Today is the sixth webinar of 5G Mobix project, and we will be addressing the challenges, the recommendation to 5G for camp deployment in cross-border scenarios. My name is Sevi Christoforou, and I am a Communications and Dissemination Officer with ICCS, which is in Athens, Greece. And I want to thank you for joining us today for a very, very interesting webinar. Just a few words about today. What we will focus on is the analysis of the challenges surrounding camp deployment in cross-border scenarios, as well as recommendation on deployment enablers stemming from the experience of the project, and particularly Work Packet 6. 5G Mobix, for those who are not familiar with the project, develops and tests automated vehicle functionalities, 5G core technological innovations along multiple cross-border corridors, such as in Spain and Portugal and Greece and Turkey, and as well as in urban trial sites, such as in France, Germany, the Netherlands, and also outside Europe, Korea, and China. The conditions are different under conditions of different vehicular traffic, also weather conditions, network coverage, service demand, as well as the project is considering the inherently distinct legal, business, and social local aspects. Now, I would like to introduce to you the speakers of today. First, by the way, you can show yourselves if you want. First, we have Dr. Olga Segu. She's a senior RID specialist with Intrasoft in Greece. She has extensive experience working as a project manager and has handled multiple projects in different technical fields. Her expertise lies mainly in cloud computing, service virtualization, cybersecurity, and the transition to 5G mobile communications. As a systems architect, she designs privacy, security, and ethical safeguards in cloud and 5G infrastructures. And in 5G Mobix is the leader of Work Packet 6, which deals with 5G for camp deployment enablers. Then we have Irene Sacco Lopez. She's a project manager at CTAG, which is the Automotive Technology Center of Galicia in Spain. And she is a new member of the 5G Mobix team. She just joined a few months ago as the coordinator of the Spanish and Portuguese cross-border corridor. Next, we have David Fidalgo. He's a technology and innovation enthusiast and also an automotive expert. He's the co-founder and vice president of IVAC. It's the Spanish Association of Autonomous and Connected Vehicles, and the founder and CEO of Y Mobility in Spain. Then we have Tahir Sari. He's a connected and autonomous vehicle engineer at the Autonomous Engineering Department at Ford Otosan in Turkey, and he's currently involved in vehicle connectivity related Horizon 2020 European projects such as 5G Mobix and Beyond 5. Then we have Roman Sacco. He's a management consultant at Dedecon with more than 5 years of experience in telecommunications and digitization consulting with public and private sector clients in Europe, Asia, and Africa. He has a quantitative background in economics and he has been working corresponding project experience in telecommunication infrastructure costing, fixed and mobile, which complements the strong interest he has in innovative business models around 5G connectivity, mobility, and automation. Then we have Roman's colleague, Andrei Sorokin. He's Carriers and Government Relations Director in Russia and CIS area at Dedecon. He has more than 70 years in experience in telecommunication industry, 9 of them working on the side of telecom operators in Eastern Europe. He has extensive hands-on experience as a mobile network architect and network rollouts manager, and he's an expert in spectrum management, licensing, and government relations. More than 5 years of experience in research and development projects on smart logistics, digital transport and digital transport corridors. Last but not least, we have Dr. Angelos Goulianos. He is a senior wireless system engineer at Satellite Applications Catapult in the UK. He is currently involved in various ICT projects targeting both satellite and 5G terrestrial connectivity. More specifically, he has been involved in the development of a hybrid communication testbed for applications to CCAM, to connected, automated, and autonomous mobility. Currently, he's participating into the development of a 5G neutral host platform utilizing the recent advances in Open RAN technology. He's also involved in the 3GPP special working group targeting the integration of satellite communications into 5G and B5G systems. So I want to welcome you all and thank you for being here. Now, Olga, would you like to present the agenda of today?
Yes, thank you. Just give me a second to show my screen.
Yes.
Okay, so thank you very much, Sevi, for the kind introduction. As you have already mentioned, within the project, we have been dedicated a lot of effort into analyzing the challenges that hinder 5G rollout, especially in cross-border scenarios. And we have been collecting extensive input from stakeholders in the area that are both internal or external to the consortium of 5G MOBICs in order to analyze these challenges and provide a set of recommendations that can enable 5G rollout in cross-border areas. So within the first session, we will give you a glimpse of the first results in this area regarding the challenges that we have uncovered in our own CBCs and the recommendations and the prioritization of the recommendations that we have performed during the project, as well as some of the business and cooperation issues that we have uncovered. So within session 2, we are taking a look into some of the aspects that concern pre-deployment studies, such as, first of all, a pre-deployment study that is being performed on behalf of 5G MOBICs by DETECOM. This sort of work has been mandated by the Commission itself because they need to have a very close look on how costly a deployment can turn out to be in a cross-border area. So we are taking a look into a few specific selected CBCs across Europe. Furthermore, we are taking a look into how satellite communication can be integrated into this context in order to improve coverage in cross-border areas. So without further ado, I will pass the floor to Irene Sacco, and we can start with session 1 that analyzes the challenges and recommendations that have come from extensive stakeholder input collection. Okay, thank you, and I hope you find the webinar interesting and informative for you.
Thank you, Olga. Before we go to Irene, I just also want to give you some information about the process before we get started. You can use the chat box in case you have any technical issues to address them to the organizers, and please use the question box to address any questions to the speakers. Throughout the sessions, we will have a few minutes dedicated to a Q&A session at the end of the webinar. And when you ask a question, make sure to also have the name of the speaker so we know exactly who to assign the question to. Thank you, and Irene, the floor is all yours.
Thank you, Will. Can you see my screen correctly?
Yes.
Perfect. So good morning, everyone, and thank you to be here with us. My name is Irene Sacco, and I work at CITA. I'm going to present together with David Fidalgo from IBAC the work done in task 6.1. This is in relation to challenge and recommendation to 5G from CAM deployment in cross-border scenarios in the framework of the 5G modules project. So I will briefly outline the main challenge identified for the development and deployment for 5G for CAM, and it firstly identified in general and then specifically in the Spanish-Portuguese corridor, where I will comment about the cross-border issues. David will then briefly show some recommendations that will help address this challenge and how these recommendations have been prioritized. So briefly, I present the main factors adapted as a methodology. I started with the analysis of the technology as well as the required 5G needs to support the different requirements of the CAM functionalities. Next, the industry was monitored through interviews and the review of current projects, which allow us to understand and assess the main actors involved in the 5G value chain for CAM. And also, the related costs that affect the deployment of the technology were also studied. Finally, some recommendations for the deployment of 5G for CAM it were made in order to validate and prioritize the deployment of the 5G CAM. So regarding the main purpose of this webinar, I would first like to present those challenges identified at a more generic level that are common to any deployment anywhere. After this, I would like to present some challenges identified at a particular level in the corridor and the so-called cross-border issues. Therefore, I will focus on 6 challenges that have been identified and analyzed as the main ones to achieve an effective development and deployment. These are deployment, data, application and interoperability, cybersecurity, automotive industry and CAM, and to close, road. I will go to explain each one under their own classification. So regarding the deployment, the implementation of a new mobile communication technology implies the deployment of a novel network architecture. Therefore, the availability of new 5G equipment depends on vendor capability to manufacture the elements according to this new architecture. So vendors, in turn, depend on the manufacturing of the standardization by 3GPP to be able to develop their the new network products and also gradually add new functionalities to this device. For use cases such as CAM, it is necessary that the technology involves a new deployments become available. As an example, some of actual automotive application cannot be fully tested if the technology is not yet totally deployed. So, in conclusion, the cooperation between vendors and operators and a common standardization is a key for the deployment of 5G networks and the implementation of new use cases like all the ones related to CAM. Some considerations must be provided in this new network to deploy it. The first one, the mentioning each element for 5G speed. So a neat end-to-end evolution plan is needed for it. And also continuous upgrade core, radio and all transport links connected them. The second one is a distributed cloud-based architecture is mandatory, where much of the network must be pushed to the edge using cloud technology. It considers that ultra-low latency application will be extremely difficult to create without a localized service provision. This is due to the only limitation of the speed at which light travels into the fiber, about 100 kilometers in a millisecond round trip. The third one is the security. Needs to be incorporated into every element of the network and also embedded in every step of the network operation. And the last one is a new end-to-end cloud-native secure 5G architecture to handle the complexity of many different CAM use cases. It's solely ready to serve customer beyond customer, and end-to-end slicing should allow CAM application to be individually customized. Once the network deployment is complete, network optimizations becomes a key job to ensure that the network provides the desired performance. Hence, preliminary field tests are strictly necessary to identify possible issues in the 5G network. Specifically for the Spanish and Portuguese corridor in the Spanish side of the border, these tests were executed when the deployment of the 5G network was concluded. That was in February 2020. And as a result, some problems were discovered and work was needed to improve network performance. To comment with experience of real test carried out, for example, is one of the issues that was be detected was a small radio power in the border and also regions without 5G coverage in testing areas. This made us aware that antenna location need to be carefully studied and that each 5G site should be located at an optimal or good distance from the border, so that downlink and uplink performance will not be compromised in a negative way. So the search for the best possible radio link configuration is necessary, and in addition, that is clear, having the best equipment ensures the quality of connection and communication. The next challenge refers to data. The information and data generated by sensors and an application was analyzed under two key aspects. The first one is the data quality validity. The data must ensure robustness, consistency, credibility, and reliability. That is it's a critical safety issue if data quality validity is not achieved. It should be taken into account also the weighting of the different route users, also the statistical relevance of the data, and also the relevance of the time validity and the life cycle of the data. That is, as vehicles will share data and the temporal context may be different in agility. So slow, for example, in case of road works or very dynamic for vehicle positions. And it might even be confusing if the sample is very close. That is, for example, the traffic light state. And from the data property and management is built into two key pillars. That is the transparency and fair competition, and focused on economic aspect of the reuse of information. From CAM use and other involved actors, that is like the autonomous vehicle, the European framework guidelines should be considered. Some of them are the General Data Protection Regulation, with some difference in the implementation of this level in the cross-border corridor. Between the infrastructure operation were identified as a barrier to their cooperation. Also, the guidelines for the artificial intelligence, which should be applied to CAM use cases to ensure the artificial intelligence does not have a negative impact. And also the Open Data Directive, which provides a common legal framework for an European data market, and it will be also applied especially for public sector stakeholders in CAM. Regarding application and interoperability, as I commented before, that's a part of the core automated driving function. The application must be reliable and robust, so the infrastructure must be designed for a possible combination and also be interoperable. Therefore, these applications are part of an infrastructure that connects many other applications, so that a failure in one of the elements can never lead to a critical security situation. When considering all of this, two categories of measures stand to consider for 5G CAN deployment. That's the interaction between application and network, and also standardization across countries and OEMs. The next one is the cybersecurity. We identified 7 cybersecurity challenges according to the ENISA. I will not go into more detail because this point could be the subject of another exclusive webinar. I get direct to the automotive industry and CAN. That is clear that the automotive industry is one of the most competitive industries. The OEMs can see also that with the help of the 5G application, it will be possible to send data from vehicle sensors or infrastructure to edge or cloud centers, and have been designed in these centers and transferred to the autonomous vehicles. So this type of services could optimize the advance in vehicle sensors, even reducing the vehicle production cost. Also, in addition, the OEMs will be able to offer new and improved services to their customers with the help of the 5G, such as teleoperated driving or automated vehicle operations and more of them. So that 5G is quite important for the future services provided by OEM. And more work needs to be done to address the challenge and question that it represents of the crisis. The last one is the road. And here the 5G technology can play also an important role by connecting people, vehicles on the move with road infrastructure and road operations. The main operational objectives for road operation in this point are to improve the road safety, optimize traffic flow, manage incidents, and effectively manage conservation and construction work. Also provide the traveler with timely and accuracy information. The connection between people, circulating vehicles, road infrastructure, and road operators can play a very, very important role in safety, operational efficiency, mobility and comfort, and environment. However, for the road operator point of view, there are several issues and challenges that need to be addressed. We identify some of them. The first one is the spectrum. At this point, the long time scale for agreement on spectrum use are already having an impact on 5G deployment and also direct impact on 5G mobility projects. Another point inside this spectrum challenge is the harmonization of the spectrum allocation across regions and countries. That is a very important challenge also. And regarding the standardization, I commented also before, and 5G deployment is ahead of regulatory standards, so initial 5G deployments will not meet standards as they are not deployed yet. Regarding the coverage, 5G offers a significant increase in speed and bandwidth, but it is more limited in range and therefore requires more infrastructure. And from the road operation point of view, this implies efficiency or rationalization of current equipment. Also the implementation costs and the security and privacy. Regarding the security and privacy, the road operation must ensure that data virtualization and cloud-based services are as hermetic as possible to protect users' data and privacy from cybersecurity threats, for example. And also, the road operator platform should host only anonymized user data. Finish this point, I'm going to deep in the cross-border challenge and this cross-border, issues. Sorry, that is. Okay, so as a result of the previous analysis, in the early stage of the project, the technical team made an initial proposal of the main challenge applied in cross-border areas of 5G technology for the CAM. These have been collected and classified into categories to facilitate their analysis and subsequent implementation for possible solutions or mitigations. A total of 7 issues were identified as cross-border issues to work on possible mitigations inside the project. I will explain these identified issues below then into their categories. The first one is the telecommunication issues. And inside this category, we identified 6 cross-border issues. To name a few, the project is currently working on minimizing the roaming disruptions and also the latencies. So we have the 3 first cross-border issues, the NSA roaming interruption, SA roaming interruption, and also the inter-PLMN interconnection latency. Another important issue is the typology of the area in terms of population. In the border, it is very sparse and dispersed in these border areas, which hinders the continuity of the 5G network. So this low coverage areas are another big important cross-border issue. And we have 2 more, the session and service continuity and the data routing. Regarding the telecommunication and application issue, this is the both category together. We have an issue regarding the insufficient accuracy of GPS positioning. So there, the global navigation satellite systems cannot meet the stringent count requirements down to 20 or 30 centimeters accuracy. It works not properly indoors, also in parking, tunnels, lower decks, for example, and have a strong limitation in dense urban environments. Without accurate geopositioning, CAM application that requires external information based on absolute positioning cannot merge this information into local maps with relative position. And also regarding the application issues, we have 2, the dynamic QoS continuity and also the data protocol stack interoperability. Regarding this point, the inconsistent data scheme and protocols complicate the exchange of information and the overall communication between vehicles from different providers, different networks, also domains and infrastructure system or federated services. The cross-border context amplifies this situation. Regarding the application issue that we have that's regarding the regulatory. Sorry, I have a fail there. And we identify both issues: the geo-constrained information dissemination to achieve relevant data reception, and also law enforcement interaction. So with all these challenges identified and all the cross-border issues also identified, we plan to give the next steps to minimize the impact and to get a well-deployed and development for the 5G for CAM. That's all from my side. Now I give the floor to Davis so that he can present some recommendations for this challenge. And from my side, thank you for your attention. I don't know if David, are you?
Sorry. Yeah, I'm here. Hello, everybody. So thank you for the introduction, Irene. Basically, as you can hear for Irene's presentation, we have several number of challenges in different corridors. The aim of the project was trying to understand some of the challenge, but basically we have different challenges in different corridors, and one of the objectives that we were trying to get as well is just trying to understanding those particular challenges to providing a set of recommendations that I guess could be applicable for the more of the macro level point of view of the 5G CAN deployment. So as you probably understand, this is a project, as Irene mentioned, of research. So the intention for us was trying to analyze all the issues and challenges to understanding how will be the deployment of 5G CAN at European level. At the same time, understanding as well what actually will be the impacts on the corridors, because some of the issues that they have in the different corridors, they were common, or some of the issues weren't specific for a corridor, or some of the issues were actually common, but we need to actually creating some kind of a common ground. And the intention what we're trying to do ourselves was trying to actually as well getting all the issues at macro level on the European level, seeing the whole territory impact, and in the CAN corridor, they're in the specific corridors, and validated it and analyzing it against the different stakeholders to make sure that we can actually creating a set of recommendations that we can put forward after all the challenges that were happening or they being identified for the whole team. So as you put next slides, please. So the objective what we have was trying to, when we actually do this exercise, we're trying to categorize all the issues. So we getting all the, what we're seeing, we have different issues in different areas of technology and in the deployment as well. So we're trying to analyze that particular issues and categorize it in areas. These areas where we categorize in some of the issues to develop the recommendations, we're trying to validate it across stakeholders, industry and practice and standards, because basically there was a lot of standards since basically the project was started, and then we were trying to, the output we were trying to get, it was trying to get a set of recommendations that basically they can be contain all the challenges and issues and solutions that actually is being applied in each of the different corridors. Right. The other thing that we thought that it will be interesting to do was creating an evaluation criteria to understanding the usability versus the life cycle cost to prioritize those particular recommendations. So after the study, we actually come to 13 golden recommendations, and today I want to explain you a little bit how we did the evaluation, the areas, and a little bit of some of the recommendations that are being highlighted as priority. So next slide, please. So the evaluation criteria, in order to take this, we actually divided the impact that we're going to have on each of the different issues, challenges, and solutions into the stakeholders. So impact to the major stakeholders of the project, including in the analysis, the road infrastructure, network operators, MVNOs, automotive OEMs, local and national governments, and the EU as a whole, right? The impact on the EU, so we'll be evaluating the impact on the different technical areas as well. 4 technical areas in deployment and competitive value and business value, the criticality, so in terms of how this recommendation is critical to actually taking action to solve it or to suggesting a plan of action for that recommendation, and compare that with the life cycle cost and return of investment for the utilization of that particular recommendation and the cost. So we take this particular criteria to starting to analyzing some of the issues and then categorize it. We come with, if you go to the next slide, please. We come with 6 categories, right? In which basically we, so it was the 5G architecture category, the 5G network, legal and standards, stakeholder collaboration, and road infrastructure, as well as business models. When we actually set up all the classification and configuration of the issues, we came in with the 13 golden rules, and then what we did basically was trying to go outside to the industry experts, or actually to the network experts on 5G AA and 5G BBP, as well as like in the legal and standard sector, to the ISO, ITU, IEEE, SEE, World Economic Forum, and the UN, to understanding what actually are the different standards and regulations and practice that they're currently using in the industry to solve this problem, because obviously since the project started, there's been some developments in the infrastructure industry, as well in automotive industry, and as well in the road infrastructure, to understanding how basically some of our issues, they actually could be solved with some of the current standards as well. Obviously, there's some gaps that we can recommend in under these recommendations to provide a guidance to the next steps that we need to do with the 5G CAN development. Next slide, please. So here is just kind of like, I mean, by the way, all this information is going to be released on the, because it's a quite healthy and long process when we get there. But what we want to highlight here is basically just some of the scoring system that we're using to prioritize in some of the recommendations. So the utility costs, basically, we're including 6 different areas, right? That we're trying to focusing on the user value and the business value, on the technical value, on the operational value, and the standardization value, as well as the criticality of that particular recommendation. And then the life cycle cost, as you can see here, we use a score to try to understand the priority in terms of is very low, very high, depending on the cost of research, deployment, cost of deploy, cost of integrate, and then that is part of the acquisition of the life cycle value, and then the utilization that we're gonna have it in. So all those recommendations, the CVCs that basically recommendations are in 90%, and the golden recommendations were actually apply the same evaluation criteria. And then that will allow us to prioritize in terms of the main recommendations and priorities we need to take for our next steps. So next slide. So after all this, we actually found they were quite scoring quite high in both of the recommendations. So the 13 recommendations we provided, and basically we have, funny enough, most of the priorities actually are coming into some of the recommendations that they're related with the 5G network and implementation of the 5G network. The 5G architecture is coming quite high as well. The way we define the 5G architecture, it was basically the whole system of systems architecture. So we're including basically the vehicles, as well as the infrastructure, as well as the roads, right? That all of them need to be actually integrating in a more holistic architecture, right? The 5G network is basically the thing most of the people will understand, that is mainly the network of 5G for the MVNOs providing it. And the business models as stakeholders, we divided that in terms of understanding what is the business model we need to create to actually make sure that we enable collaboration, and basically the stakeholders, we were actually defining them as how the stakeholders need to coordinate themselves to actually have a much more coordination, or to actually take in action to take decisions to deploy a solution. And basically, I'm going to go a little bit faster because I think we're okay on time. But the next slide, I just wanted to show you a little bit here some of the areas that we've been highlighting. I'm going to go in detail with the different recommendations, but basically on the 5G architecture, there were 2 particular recommendations that they were focusing on the use of more standards that has been developed in the automotive industry for different standards development for SOTIF and the IEEE and ITU, to creating a little bit more of a more holistic approach to the architecture, in which some of the requirements of the MVNOs can be included on the vehicle as well, and some of the requirements of the vehicle can be actually taken in consideration for the MVNO. The second recommendation, number 2, was talking more about the infrastructure legislation and the framework that need to be created to have a commonality for the technology commonality on some of the different applications, to enable that they have a consistency on signaling and protocols in some of the areas in terms of the geography as well. Next slide, please. The number 7 that it was trying to promote that the MVNOs need to working with or collaborating to understanding more the business models between all the different stakeholders. In this particular project, where the stakeholders were identified were like the road infrastructures, the automotive OEMs, the governments, as well as the network operators. And the 5G number 8 and number 9, we were focused quite heavily on spectrum, right? Legislation of the framework for creating more of a framework in Europe. I mean, there's been some frameworks created in the US and in China as well to tackle this particular challenge. So the both recommendations we're talking about creating more harmonization of the network and then creating as well a standardization framework in which basically can creating some collaboration to understand the technical and the business model that need to be applied to ensure that everybody actually can working with the same roadmap to achieve the development of or implementation of 5G CAN. You go next slide, please. Then there was a lot of issues and recommendations regarding with legal and standards. So I'm gonna go into detail into them, but it was obviously as Irene mentioned, there were quite a lot of problems with the edge cloud infrastructure and the cybersecurity challenge that we are having into this particular area. And at the same time, we were finding out that there was being a lot of work as we've been doing on that particular area with some of the new regulations that UN actually putting in place last year as well, and then some of the other bodies that actually were working in some of these particular standards. However, there's still some gaps in some of the standards for actually tackling some of the challenges and issues that is being highlighted in this particular project. So we're actually recommending a few different approaches to understanding more how we can actually close in these gaps in the standardization that we currently have to allow a much better integration of the 5G CAN in Europe. And I think, if I'm correct, this is all for me. So thank you very much for your attention.
Thank you so much, Irene and David. And now Tahir.
Hi.
The floor is yours.
Share my screen. Thank you very much. Yeah. Okay. Thank you very much. So just clicking. Do you see my screen?
Yes, perfect.
Okay. Thank you very much. Welcome everybody. This is Tai from Ford Otosan. I'm going to explain about the business and cooperation models that we studied in Deliverable 6.2 in 5G Mobix project. Let me explain what is the content. Business model canvas for the user story we studied, and the volume network model to see the 5G 4CAM stakeholder relationship and the motivation, business related gaps and recommendation. And these are, by the way, about only business models, not the technical stuff. We will touch so many. And the next steps later about our study. Okay, so business model canvas, maybe you are not familiar with it, but it's basically explains first you just create a table like this and explain your value proposition, and then you just fill the other columns like the key partners, like the activities, the key resources, etc. So here you are seeing platooning with See What I See application and the business model canvas, and this is actually can be found in our 5G Mobix website deliverables section. Here, as you can see here, what is the proposition, value proposition of the platooning? For example, decrease in logistic costs and decreasing fuel consumption and reduction of carbon dioxide emissions, etc. So, and we take a look at this from the different stakeholders' perspective. For example, you're an OEM, like automotive OEM, like Ford, and your customers, in this case, the truck drivers, the fleet owners, as an example. And we categorize the OEM and road operators as an A letter, capital letter. And just let me show you here. I think you are seeing my mouse also. For example, customer relationship for the A, which is the OEM, also covers the on-site support after sales, onboard remote support, and the call center support, etc. So, and then what are the key partners, for example, for the A, the OEM and road operators, the tier 1 OBU suppliers, road operators, public authorities, and the cloud providers, etc. And we filled this kind of business model canvas for our all user stories in 5G Mobix projects, and it will be shared in the deliverable 6.6. Currently, only platooning with See What I See is shared in deliverable 6.2, and it can be found, as I mentioned previously, on our website. So here we just try to create a new business over the platooning with See What I See application. And as a next step, this business model is not enough only to understand the interaction with the other stakeholders. So we just created the value network model. So what is it? And it's actually quite complex, to be honest. This is one of the issue right now for the 5G 4CAM. So 3 months ago on the March, end of the March, we had another webinar, and then we also touched that point. So here you can see that the automotive industry and the telecom industry are the main clusters for the 5G 4CAM applications. And here, what are the automotive OEM industry partners are here OEMs, the tier 1 suppliers, component manufacturers, technology providers, and they are interacting with the telecom operators and also interacting with the insurance companies, end users, and also other cloud operators, etc. And of course, standards development and organizations, R&D organizations also filling the gap and providing some insights to the other partners. And also here, telecom industry, what we have, the telecom vendors like Ericsson, Nokia, Huawei, and the telecom operators like Turkcell in our corridor, and Cosmote in Greece corridor, NOS in Portuguese, and Telefonica, etc. in Spain, and other telecom technology providers and cloud providers are also other stakeholders that we have in telecom industry cluster. And policy makers, of course, providing their insight and to the whole ecosystem. And as I explained the main graphic for the value network model here, we just did our study per user story in 5G Mobix project. So I'm just gonna show briefly what are those, how they are look like. But as you can see here, it's kind of a complex but detailed completely in deliverable 6.2. If you just visit our website, you will see all explanations, how as per user story these stakeholders interact with each other and what they provide, what they will benefit from, etc. Yeah. So as this third part, the motivation of the stakeholders. So if you want to commonize the 5G 4CAM deployments on the cross-border area and also on the rural area in Europe, we need to motivate the stakeholders that I mentioned previously. So what some of them are briefly explained here, but please check our deliverable for the more detailed summary, because it's not enough to, we don't have enough time to explain all motivation points of the stakeholders, but mainly for the MNOs, the operators, telecom operators. So a new differentiation ways. What are these? Are, for example, currently the telecom operators mainly commercialize their power of the download speed and upload speed, etc. But now they can also use the benefit of the ultra reliable low latency communication, and also eMMB, and also multiple connection in a 1 kilometer squares. So this is a 5G provides this famous triangle. They can also use this as a advantage to then differentiate their the power with the between the customers with the, and among the other operators. And expected 5G services. Of course, as an automotive OEM, we are looking for the 5G opportunities. For example, the private 5G for our factory. For example, they can interact with the other stakeholders and then create their service in a company, in a factory, for example. And also if they can improve what they are doing right now for the customer experiences. 5G provides much more downlink, as you can imagine right now. It's also in Europe, in England exists, for example, in Germany also. And for the automotive industry, the fully autonomous and connected vehicles is on the horizon, and we need 5G to enable fully autonomous and connected vehicles. And also the automotive OEMs will become a platform supplier. The vehicles are not going to be a part of only the transportation, but also they will communicate with each other, and also they will act like a mobile phone, for example, and they can communicate with even your home, and such services can be provided with the help of the software inside of the vehicle, infotainment system, etc. And of course, automotive OEMs can advertise their safety and the improved customer experience. Like today we see on the, for example, the Tesla and the BMW, like Ford, we of course touching this increased safety with the connectivity and new experiences. What about the hardware and software suppliers? Of course, new collaboration opportunities, such as NVIDIA. I can give an example very briefly. They just improve their hardwares to communicate with the vehicle, autonomous vehicle infrastructure, and also inside of the autonomous vehicle. And of course, some modem providers. Just now we are seeing they are providing their 5G modems, 5G capable modems, or 4G right now for the connected vehicles. So this is the new interaction between the automotive OEMs and the hardware suppliers, for example. And also for the fully 5G and connected autonomous vehicle, new validation and certification procedures will exist, and for these proposed, the hardware and suppliers will work common with the authorities and also with the OEMs. And also about the road operators' perspective and CITS centers' perspective. The road operators can be part of the 5G infrastructure itself, so they can be the 5G provider on the specific section of the road. So they can help the MNOs to establish the 5G connectivity on the road, and also the service differentiation. So the autonomous vehicle owners can choose the road sections that capable of 5G connectivity. So they can, the road operators can offer their road, advertise their road capabilities with this 5G. And of course, they can increase their control on the road. And from R&D institutions' perspective, they want to right now understood the socio-economical impact of 5G for CAM and also scientific advancement in the network connectivity and CAM technologies. They can work on these and gather some investment from the EU and also improve their knowledge and collaborate with the industry to improve their knowledge and share their knowledge, etc. And for the transport operators, on the other hand, such as the fleet owners, they can advertise the reduced probability of accident and also improve journey times, and also driver fatigue will be reduced, so that will be help to transport operators to travel much more than the currently they do. And the other hand, the business related gaps I want to touch. We just use the PESTILE approach, so it touches the political, economical, social, technological, legal, and environmental gaps on a specific area. So on our case, the 5G for CAM. So politically, currently, what is the missing? And we see that the difficulty in harmonizing and coordinating policies and standardization between different companies and countries, and economically, lack of motivation of the investment right now, because right now the 5G is quite new and the investment motivation is not that much high that we expect so far. We need to improve this, and also on the social side, public lack of trust to the automated vehicles, and today nowadays we are seeing some people believe that the 5G is causing the COVID-19. So this is of course, we need to solve this kind of public trust, and we need to explain that what is what. And we need to, of course, also on the other hand, solve the concerns about the job security, because we are bringing 5G for CAM, and this will maybe for the truck drivers, they might think that they will lose their job, but the 5G for CAM will create a new job opportunities. We need to touch this also. And on the technological side, what are the barriers? Disparities in the capability of the EU member states are different. So member states some of them are very tend to invest on 5G, but some of them are not currently. And ethically, think of customer choice with a different technology. Should I use 5G for CAM? Should I use vehicle to vehicle, or should I use for example, 4G for this application? We need to solve this. So on the legal perspective, unclear how to ensure protection of customer rights, difficulty in determining accountability in case of accidents, environmental development of environmentally sustainable and also economically affordable vehicles. This need to be solved. There are lots of other gaps that we pointed, but because of the lack of time, I couldn't wrote here. So please check our website. Again, I'm repeating myself, sorry, for the more gaps that we defined. For the recommendations, I just want to touch briefly also. We need to create a cost-benefit analysis to jumpstart the cross-border corridor deployments, 5G deployments. And also, we need to analyze competitive forces in cross-border corridors. We need to foster job creation and upgrade skills in the existing workforce. We need to improve the 5G knowledge, 5G for CAM knowledge, and we need to create a data economy, legislating for the future and creating clear liability borders. Liability here is who will be responsible from what in case of accident, or the creating a 5G 5G4 service, because as I mentioned previously, that it's right now 5G4 application interactions are quite complex. We need to reduce this, and we need to guarantee the customer choices, avoid locking condition. For example, customers should be able to change operators or sell their cards in the future easily. And also we need to have the open discussion about machine ethics. These are some of the recommendations about the business-related 5G4 development, deployment. Please ask your questions if you have in your mind. But for now, this is my next steps also. I just forgot to mention. Last section is the next step. So this is our first version of the deliverable 6.2. The second version will be 6.6, and it will be also on our website end of the middle of the next year, 2022. We will share some questionnaires with you. It will be very nice if you can share some answers with us later, not after this meeting, of course. And also we will improve our motivation, recommendation, and business-related gaps according to the field questionnaires, answered questionnaires, and our workshops. And of course, we will have trials on the cross-border, and then we will come back to our deliverable and improve related sections. And also we will examine other projects and compare with our findings. These are for now our next steps. Now this is the end. Thank you very much for listening to me, and please write your questions on the chat screen in case of you have. Thank you very much for listening.
Thank you so much, Tahir. And now we will move to session 2 on deployment study in European cross-border corridors. And I will give the floor to Roman. Roman? You're muted.
Actually, can you hear me now?
Yes, we can hear you now.
Okay, perfect. Just let me share my screen. Is it visible already?
Yes, if you put it on. Yeah, perfect.
Okay. Cool. Yeah, thank you. First of all, very much of Olga and Servi for the introduction, and also to the previous speakers, Tahir, David, and Irina, for the very interesting contributions. So yeah, my name is Roman from Deticon, and I would like to continue now with the CAM pre-deployment study. So what we are focusing on is basically the cost of the infrastructure needed, and I will present this together with my colleague Andre. We'd like to highlight here that this project or our study has received funding from the European Union's Horizon 2020 fund, and yes, then I would like to continue and actually show you what we are going to present. Maybe as a heads up, the study is still kind of in the middle of it now. We're deep in the progress, and so far we can't present actual results so far, but we are going to focus more in this short presentation on our approach and how we tackle the problem. So first, let me just drop a few words on who we are as Deticon, because this is also our first time presenting here in the 5G MOVIX community. So just so you know who we are. And then on the second step, I would like to move on to present the key objective of our deployment study. And as a third part, I would like to show you what is the scope actually, both in terms of the geographical scope, because it's slightly different than what has been done so far, as well as the technical scope, mainly feeding from the use cases. Then I would like to highlight our approach, or explain our approach. Mainly there are three parts of it: the interviews, the radio planning, and the costing. And the radio planning will then be presented by my colleague Andre. Then also we would like to, since we don't have proper results at this point, but still we've conducted a lot of interviews, so we would like to give some of the impressions that we have gained so far from speaking to lots of stakeholders in the industry. And there may be some overlaps with what has been previously presented, but I think that it's still valuable to get the confirmation from the interviews that we have also conducted. And then finally, also we would like to show our contacts. So just in case, I believe there will be a Q&A at the end of the webinar to pose questions directly. But of course, if there come questions later on, you can feel free to reach out using the contacts provided. Okay, so let me start just briefly on how who we are as a company. We're Datacom Consulting. We're a German consultancy that's been around for 40 years, and the roots lie within telecommunications, and we still have a lot of our businesses going on in telecommunications. However, over the past decades, we have also broadened a little bit into the into the areas of general digitizations in other industries besides the telecommunications. So, for example, in the automotive sector, and we are tackling there all kinds of digitization business models, and we are actually quite global, distributed. We have offices in San Francisco, Bangkok, and so on. I'm here in Cologne in the headquarters, and we have a very broad background, so to say, but mainly in telecommunications. And in this context is also what the study is focusing on. Basically, we've heard it a lot now. The 5G infrastructure is missing, particularly in rural cross-border areas, and this is the key objective of our study. So you see here, it's about the investment gap, so to say. That investment gap refers to the 5G infrastructure that is needed to enable CAM traffic along the cross-border scenarios. So what does that actually mean? We have basically two underlying key assumptions that create this investment gap. And the one of them is that the CAM traffic requirements are expected to increase. So that means we will see more and more connected automated vehicles on the road, and these, of course, drive up the requirements for the 5G networks. On the other hand, you have also the situation that the MNOs, or the mobile operators, they have very little investment incentives, particularly in these rural cross-border areas. So, I mean, in urban scenarios, it's let's say expected to be solved in the coming years, that the 5G deployment is very soon, or in some cases already is sufficient for a lot of the use cases from CAM. But particularly in larger countries, in cross-border areas, there is a lack of this telecommunications infrastructure, and that leaves us with the investment delta that we refer to here. So the fact that the 5G infrastructure planned by the mobile operators will not be sufficient to support CAV, connected automated vehicle use cases in cross-border areas due to the lacking market incentives. So what you see here on the right side is a visualization of this investment gap. To just briefly explain the graphic, you can see that the x-axis is our baseline that we basically refers to the existing infrastructure. So mainly 4G and 3G in the cross-border corridors that we are looking at. I will show them on the next slide exactly to know for you to know which ones we are talking about. So the x-axis represents this infrastructural baseline, so basically the as-is state. Then the dark blue. Okay, so the dark blue. Sorry, can you still hear me? I'm getting a little notification here that there's a connectivity issue.
We can hear you. We cannot see you.
Okay.
But we can hear you.
Right. Okay. Good. Then I'm just going to continue without the camera. I guess that dropped. So the dark blue is basically showing what is planned by the operators, and this we are investigating mainly through our questionnaires and research. So we are trying to talk to the industry representatives and finding out what they are actually planning to deploy and invest in terms of infrastructure along these corridors. Then at the same time, and this is what Andre will also talk a little bit about, we are doing a high-level radio planning for these corridors to understand what would be the cost, hypothetically speaking, that is necessary to provide the infrastructure that supports the CAM use cases that we're looking at. And of course, based on the assumptions, there will be a gap or the delta that we see here. Okay, so yeah, now I have the laser pointer. So this is illustrative, of course, and we're doing the whole exercise for 2023 and 2025. I guess I need to speed up a little bit. So we have here the cross-border corridors that we're looking at. Two of them are already known. They are highlighted here in red. This is also where the trial sites are in Portugal, Spain, across the Minho River, and then in Greece and Turkey at Uppsala border crossing. And then in addition to those, we have added 3 border crossings corresponding to the trial site countries a little bit. So all the way up in the north, we have this crossing between Norway and Finland. Then we have one between the Netherlands and Germany, and then finally at the Spanish-French border close to the Mediterranean Sea here. So these are the 5 border crossings, and these are the use cases. They should probably be known to most of the people familiar with 5G MOBIX. So we have advanced driving, extended sensors, vehicles platooning, QoS support, and remote driving. And based on these, we have different network requirements here in terms of latency, bit rates, and mobility, and of course the reliability that has to be provided by the networks. So how do we get to this investment gap? This is our approach. I already mentioned it. We do a very broad stakeholder survey and try to understand the requirements and expectations in terms of investments from the whole ecosystem, more or less. Of course, we're focusing on the mobile operators and also as a secondary 5G connectivity provider, potential provider, the road operators. And then we also talk to the automotive industry to understand their requirements, as well as some other stakeholders. So this first identification period has been completed more or less. And we are now, we've started now phase 2 and 3. So we are basically evaluating the information we gathered and based on that, doing the network design and all this aims, of course, at coming up with a cost of the infrastructure gap or delta in these 5 corridors. So we do that using the radio planning, basically identifying what additional infrastructure is needed. And yes, on this, my colleague Andre will now explain a little bit. So let me hand over to you, Andre. Thank you.
Yeah, thank you, Roman. Colleagues, it's Andre Sorokin speaking. Do you hear me? It's okay?
Yes, we can hear you.
Okay, good. So a couple words about our approach to radio planning. So what we are doing, we are gathering data about existing infrastructure. First of all, it's radio access network infrastructure, because radio seems to be the main cost driver for the coverage of the cross-border corridors and the corridors in general, with the required quality and reliability parameters. So here, for example, we took, just for illustration, we took a part of the corridor identified within the project between Netherlands and Germany, A12 in Germany, in Netherlands, and 3 in Germany. It's marked here in the purple color. Green dots here, these are existing base stations. Actually, these are stations, they are already 5G base stations. On the right-hand side, we modeled in our radio planning tool a coverage, 5G coverage, based on this existing data. And here we see, Roman, could you please switch the slide? yeah, here we see that there are several really big gaps along this highway. Yeah, and we see that nowadays operators, they are covering with 5G mostly cities or villages close to the routes, but not the routes, not the highways. Yeah, and it's not enough to provide the services and the use cases defined within the 5G Mobix project. So we identified these gaps. I can explain here. The brown color means the best signal, green color means normal signal, and blue and dark blue, it's the worst signal. So we see that along the corridor there are not too many brown areas, so these are the gaps. And then we did some modeling. The next slide, please. Yeah, we added here the stations. They are in dark blue dots. We put them next to the highway with two sectors with 180 degrees between of them, and we see that now it's getting better. So what are observations and preliminary conclusions? That not really all the existing infrastructure sites can serve the corridors, because either they are located far from highways, or the existing height of antenna is not enough to cover the highway with the requested parameters, because some of them are installed on the rooftops in the cities, and they are just covering streets across this base station, and its signal level is not enough to cover the highways. Yeah, and how these gaps could be covered? Either we can add potentially somewhere additional sectors which will be looking at the highways, or additional sites should be built and installed, and that will already cost some money, and this cost should be calculated within our survey. I think in general that's it from my side. So just first observation and our methodology, how we do it.
Thanks, Andrei. Then maybe just as a last step, I see we are a little bit over time, so I'll try to make it quick and not repeat what has been talked about before. But our preliminary impressions, they are that there is a lot of uncertainty in the whole sector, which is also in line what we've seen before in the whole CAM ecosystem, so to say. We have different understandings of what is connected automated driving, and also regarding achieved network levels. What is interesting is that, of course, the road coverage obligations, they vary greatly from country to country. So connected to the license awards for spectrum, for example, in Portugal, there are very, let's say, far-reaching obligations for MNOs to cover roads, whereas in other countries, there are far lesser coverage obligations. And of course, these matter a lot when we talk about this investment delta. From the road operators side, we haven't so far, it seems there's no broad roadside unit deployment plan. So for providing connectivity purposes, particularly not in the regions we're looking at. Vehicular traffic forecasts are extremely uncertain due to COVID-19. The impact we saw in some of the border crossings, the traffic decreased by 30% from 2019 to 2020. So that, of course, makes it difficult to give projections. And from the automotive sector, the estimates are also relatively conservative regarding the CAV traffic fleet penetration, so to say. But I think, okay.
Roman, if you could, yes, thank you.
Yes, okay. So yeah, thank you very much for your attention. And then I'd like to hand over back to you, Stevi. Thank you.
Thank you so much, Roman and Andrei. And Angelos?
Yes, hello. Just a moment. Can you see my presentation?
Yes. If you can put it on presentation mode, yes.
Yes. So, good afternoon all. Hello from my side. My name is Angelos Goulianos. I'm a senior wireless systems engineer at Satellite Applications Catapult. And today I would like to provide a brief talk on hybrid connectivity solutions for cross-border corridors deployment, emphasizing, of course, on connected and autonomous vehicles. So the topic of my today's presentation will be first, I will describe the hybrid satellite and 5G solution that we will deploy in 5G Mobix project. Then I will discuss CCAM related use cases that satellite can offer some kind of leveraging. Thereafter, I will discuss the latest advancements on 3GPP standardization on satellite and terrestrial integration. And if time allows, I will give an overview of some of the projects we are currently working on or we have recently accomplished. As Roman discussed in the previous presentation, I'd like to get this pass and continue from his point that service continuity on CCAM is a key requirement not only for 5G Mobix project and applications, but for general connected and autonomous vehicles applications. So the cross-border corridors, we have the problem, or the cross-border corridors might be affected from roaming delays, handover delays, and most importantly, coverage gaps, as we've seen previously. And the reason for this is that mobile network operators do not deploy sufficient 4G and 5G infrastructure to cross-border corridors. And the simple reason is that this is not economically viable due to the fact that not enough customers are being served. So under this context, we think the satellite communications may offer an economically viable alternative. And there is a lot of going on in investigation from mobile network operators such as Vodafone or British Telecoms and vendors such as Ericsson that investing time and research budget on non-terrestrial networks for remote and rural areas. There are also activities going on 3GPP standardization body, and these activities are happening since 2018 or even earlier. So I would like to be a bit more specific and discuss the French test site use case, and then I would like to discuss what are we proposing in order to alleviate the problem of coverage gaps. And so let's take, for example, this red vehicle, and due to the fact that advanced driving might be prohibited in a specific lane, or due to the fact there are some roadworks on one of the lanes, this vehicle will be instructed to change lane from the mobile edge compute platform. So what exactly happening here is that the 5G system acquires data from vehicle sensors, from road sensors data, from V2X application servers, and from traffic information databases. And the mobile edge computing platform somehow fuses this information and instructs the vehicle to change trajectory or calculate the trajectory or the new trajectory of the vehicle. So all this communication normally should happen through the 5G G-Node B base station that will communicate directly to the vehicle. However, what will happen if we are in a cross-border corridor scenario when there is signal degradation, or when at a remote area that signal connectivity is degraded? And this is where the satellite can play an important role in ensuring service continuity. So what we are proposing, you can see in the top left, the deployment is an intelligent routing engine that combines both terrestrial and satellite communication bearers. And these two bearers communicate in such a way, so when we lose connectivity from the terrestrial network, the communication will continue normally through the satellite network. Essentially, what it offers is seamless connectivity through hot failover and channel bonding. And taking a closer look in the router status, we can see that we have three simultaneously active connections, the two corresponding to cellular operators and one corresponding to the satellite operator. And we have tested in the lab this configuration. And even when we take down the two cellular connections, we've seen that we lose no packets because there is this seamless handover over the satellite network. Of course, this is the solution we will also try in the French test site as part of the 5G MOBIX. So some brief technical details on the constellation we are utilizing. Currently, we're utilizing Iridium Certus LEO constellation, low Earth orbit. It can go up to a data throughput of 1.4 megabits, and it has 100% global coverage, including polar regions. And probably some of you might wonder about on the latency. So it depends on the satellite configuration, satellite network topology. So if we have a star topology, latency can go up to 300 milliseconds. However, if we have point-to-point links, latency can go up to 40 milliseconds, from 25 to 40 milliseconds. And the reason for this is, as you can see here, we have these inter-satellite cross-links that direct the signal to a global teleport and to a gateway, and then the signal is forwarded to a customer IP core. And all this latency does not have to do due to physical constraints. The latency has to do because of all this route that the signal has to undergo. Even such, satellite latency is way better than cross-border corridor roaming delays, or even worse, than having no coverage at all. So this indicates at least a temporary relief as the minimum benefit. But we have to consider that this is just a trial, and we have to concentrate and focus on what is coming up next. And this is the important aspect of the satellite. So probably most of you know the two mega constellations that are currently being deployed. One being OneWeb, that has attracted $2.5 billion in funding. And the other one, of course, is Elon Musk's SpaceX Starlink constellation. So to start with OneWeb, there is a target constellation size of 648 satellites by end of 2022, and having a latency of 24 to 40 milliseconds, which can cover most of the CAM scenarios or use cases. I'm saying most, of course, it cannot cover some of the remote driving scenarios and so on, but it can cover vehicle platooning, advanced driving, and so on. We will discuss this later on. And also you can see that just for one satellite bearer, it can offer up to 200 megabits per second. On the other side, SpaceX Starlink has already deployed 1635 satellites, and there is a deployment roadmap of 1,500 satellites per year. And again, you can see that it can achieve latencies down to 18 milliseconds, and a single bearer can serve up to 200 megabits downlink. So what are the CAM-related use cases that the satellite can serve? We have discussed, of course, what we're planning to do in the test, in the French test site, which is actually advanced driving and distributed MEC, mobile edge computing. However, we can also use satellite for vehicle platooning, or interoperable scenario for public transport and trains, which is a use case in the Spanish-Portugal test site. Further, one of the most important applications of satellite is the MEC-to-MEC connectivity in order to ensure service continuation between successive mobile edge compute platforms. A very important use case is also the service continuity through PLMNs with shared satellite access. So you can imagine that the satellite network can act as a neutral hosting, backhauling to two MNOs belonging to different countries. So this will eliminate the need for expensive fiber backhauling, and it will simplify quite a lot the topology and the structure. And most importantly, due to the fact that MNOs do not invest much on rural areas infrastructure, satellite backhauling can be ideal for remote areas and cross-border corridors. So just a brief look on what is happening in the standards. All this discussion and all these potential advancements of satellite, due to this fact, there is an initiation body, 3GPP standard special interest group that comprise 40 industry and academia members. And the target is the integration of satellite access in 5G and 5G and beyond. You can see here a table from release 16, where you can see there are different aspects that have been studied, such as satellite access from an architectural perspective, satellite access from a new radio perspective, and what kind of solution new radio has to do in order to support non-terrestrial networks. Of course, there is a study on management and orchestration aspects. You can find details on more technical aspects of these integration aspects on 5G mobile deliverable D3.3, and all the learnings from the 5G MOBIX will be fed into these working groups, as my company, Satellite Applications Catapult, is part of this special interest group of 3GPP. So, moving on, there was the Release 16 TSG Run workshop took place last week, and non-terrestrial network is about to be selected among the candidate topics for the Release 18. So during Release 18, we're expecting that satellite terrestrial integration from a radio perspective might be standardized. There are, as I said, a lot of studies going on, and there's quite a lot of potential for this. Furthermore, there is a TSGSA workshop that will be scheduled on the 9th and the 10th of September. And there are already 3 items that will be proposed. First being support of satellite backhaul with variable bandwidth and latency. The other one is the study item on enhanced access traffic steering, switching, and splitting, which will address multi-SIM and dual connection across 2 3GPP access. Keep in mind that there is also the ATSSS that connects, that's trying to study 3GPP and non-3GPP access. And last but not least is the enhancement to 5G system that supports satellite access through multi-connectivity and regenerative payloads, which means essentially that the satellite is studied to act like G-Node B in order to direct the signal directly to 5G core and offer, let's say, direct satellite access. So I'd like to close my presentation with a couple of exemplary projects that we have successfully accomplished. One of them is offering satellite backhaul through OneWeb and geostationary satellite constellation and having a local MAC breakout. So in this case, you can see that we have a G-Node B on site that backhauls 5G traffic over 2 satellite constellations to increase capacity and reliability. And of course, we have a distributed UPF that can connect to a mobile edge compute platform in order to run local applications with minimized latency. Here you can see some more details of our testbed, just to show you that these things are currently happening. It's not just some kind, of imagination. So it's really happening, and you can see we have the 5G UEs, we have OneWeb terminals, we have the geosatellite terminals. You can see the server that we have deployed our 5G core network and the G-Node B, and you can also see the server that deploys the software for carrier and carrier bonding and aggregation of the 2 satellite links. And the various use cases we have deployed here is we have utilized standalone and non-standalone core networks, neutral host, distributed UPF, and local mobile jet compute platforms. And finally, another project is targeting aerial connectivity. This is a TCMS UK government project, and this uses rural broadband and satellite-enabled 5G deployment to support agriculture and maritime use cases. And the approach here is to deploy, as you can see, 5G clusters with secure satellite backhaul, and also deploy 5G base stations to provide connectivity to live boats and, of course, other entities. This was my last slide. Thank you very much for your attention. If you have any questions, please post them on the chat.
Thank you so much, Angelos. And okay, and thank you so much to all the speakers for their presentations. And now we have a few minutes for the Q&A session. If I can ask the speakers to show yourselves one more time for the Q&A session.
And since I cannot see a lot of questions coming in yet, I will address the first one that came in the beginning, if the presentations will be available at the end, and the answer is yes. Both the presentation slides and the recording would be available at the 5G Mobix website, if not by the end of this week, definitely the beginning of next, and you will probably receive an email notification with the link and additional information. And as Tahir also mentioned, on our website, you can find additional information about the deliverables. There is also a video repository where you can find all the videos that we've done so far with the project, and additional information about the previous developments, but also future steps. Can you hear me?
Yes.
Okay,
Yes.
good. Any questions from the audience? Even if you don't want to ask your question in writing, you can also raise your hand, so I can unmute you and ask your question directly to one of the speakers. Okay, there is a question from Ilba Grillo. Is the intention to use the OneWeb constellation for the 5G Mobix?
No. As I said, in 5G Mobix, we will not currently deploy 5G backhauling. We're just deploy satellite as an additional communication bearer. But so I was just presenting some use cases that could be utilized. So the fact that we are not using 5G Mobix, 5G backhauling, is due to the fact that it has to do with the initial proposal of the project, and the purpose of the project will not allow for 5G backhauling. However, we can test the satellite latency over LEO satellite, which is a major step, and to see what kind of timers we need to adjust in the 5G network in order to have a balance between 5G and satellite connectivity.
Thank you, Angelos. We have another question from Alexandra Rodriguez. How to deal with the security data sharing aspects in cross borders? Who would like to take this question?
Yes, I can take that question. So this is a very complicated issue when it comes to security and privacy of the data sharing. Of course, we need to take into account that the stipulations that already exist within the GDPR are always respected. So this is easier to do when it comes to the European soft borders, such as we have in the Spanish and Portuguese cross-border area. And it tends to be a bit more complicated when it comes to a hard border, such as the one we have in the Greek-Turkish corridor. But there are stipulations within the GDPR on how specifically to achieve this sort of privacy level. In terms of data sharing from the technical perspective, one solution could be the use of ethical data proxies in order to manage this sort of data exchange. So the technology that we have does allow us to, let's say, sort of anonymize strings of data on the fly. That is something that is technically feasible. Obviously, that this requires infrastructure to be in place in order to handle data in these scales, because we will be touching upon big data scales at this point. So from the technical side, there are solutions that can be applied. And from the organizational side, there are stipulations in the GDPR that cover us. One thing that is very important to keep in mind is that the massive data mining that can be performed within these services that can be used as part of an AI solution on the side of 5G or on the side of the automotive services that needs to be compliant not just with the GDPR but also with any future legislation that the Commission is planning to unveil when it comes to trustworthy AI. So this is a very complicated matter because we need to ensure that we have compliance with the EU body of law in many different cases. And on the technical side, it incurs more costs in terms of infrastructure, particularly because in these cases we are dealing with massive amounts of data. Again, that would be all on my side. I don't know if any of the other presenters want to add anything.
No? Okay, thank you, Olga. I know that Angelos needs to go already, so thank you so
Yeah.
much, Angelos.
Thank you very much. Bye-bye.
Bye-bye, good luck. I cannot see another question. Oh, here it is, sorry. This is a question from Ralph. The cross-border presentation focused on network communication for CCAM only. However, 5G also includes V2X, direct communication via PC5 side link. Will further investigation or assessment also include combinations of direct and network communication? Tahir, I can see you. Is it a question for you, maybe?
It could be. So since we are developing platooning application, and it's mainly nowadays focused on PC5 communication, we are aware of this, and we will do something different for this time. We will do cloud-based 5G over 5G platooning. And of course, we will do, as a redundancy, PC5 communication. So we will compare the results and we will see which one is suitable in which cases. Of course, this is a 5G project, and we want to show how 5G can help us about realizing the CAM applications. But of course, we are considering also PC5, cellular V2X, mainly for the short range, of course, communications. But the main motivation is using the 5G.
Thank you, Tahir. And with this, I think we can draw to an end. I want to thank you all for being here today, and thank you, Olga, for organizing this this webinar. Thank you to all the speakers and all the participants. Olga, would you like to say something before we end the webinar?
Yes, I would like to, in my turn, to thank all the presenters for the amazing work that I have presented today, and thank the attendees for their time and for their questions during the webinar. I hope that you have found this session to be quite informative and give you an idea of the real-world challenges that exist when we discuss the rollout of 5G on cross-border areas. Of course, there are so many challenges that they are often very localized to each region, especially when we have the differences between the soft borders and the hard borders. And I hope you got a flavor of what those challenges might be and how we intend to solve them in the future. So thank you a lot for your time and your attention, and have a nice afternoon.
Have a nice afternoon, everyone.
Be safe. Bye.
Yeah.
Bye.
Bye. Thank you.
Thank you, everyone.
Bye.
Bye.